In this video, we dive into creating custom loss functions in PyTorch. Learn how to tailor model training for unique machine learning tasks and enhance your model's performance. Welcome to our video on creating custom loss functions in PyTorch. Did you know that the right loss function can make or break your model's performance? In this video, we're going to explore how you can craft your own loss functions to meet unique training needs. Whether you're working with a non-standard dataset or tackling a complex problem, a custom loss function might be your secret weapon. Stick around as we break down the process step by step and show you how to integrate these functions into your training loop for optimal results. Loss functions are a crucial component in the training of machine learning models. They act as a bridge between the model's predictions and the actual results by measuring the discrepancy between the two. This measurement guides the optimization process, telling the model how to adjust its parameters to minimize error. Common loss functions like mean-squared error or cross-entropy are great for general purposes, but they might not always fit your specific needs. For instance, if you're dealing with imbalanced datasets or unique problem formulations, a custom loss function can provide a more tailored approach. By designing a custom loss function, you can directly influence how your model learns, potentially improving its performance significantly.
Custom loss functions come into play when standard options just don't cut it. Imagine you're dealing with a problem where the cost of false positives is drastically different from false negatives, such as in medical diagnosis. In such cases, a custom loss function lets you assign different weights to different types of errors, aligning the model's training process with real-world consequences. Another example is in multitask learning, where you might need to balance the learning of several objectives simultaneously. Recognizing these scenarios and understanding the potential benefits of custom loss can help you decide when it's worth diving into customization. Remember, the goal is to enhance model performance without adding unnecessary complexity. Creating a custom loss function in PyTorch is a straightforward process, thanks to its flexible framework. Start by defining a new class that inherits from PyTorch's nn.module. In the forward method, compute the losses needed. Here's where you can get creative, calculating the loss based on your specific requirements. PyTorch's autograd will handle the gradients for you, which is a huge plus. Once defined, test your function with expected inputs to ensure it behaves correctly. A common pitfall is neglecting edge cases, so be sure to handle these properly. With this foundation, you're ready to integrate your custom loss into a training loop, setting the stage for improved model performance. Integrating a custom loss function into your PyTorch training loop is as simple as swapping it in place of a standard loss during optimization. Begin by defining your custom loss function as previously outlined, then use it within your training loop to compute the loss for each batch of data. Pay close attention to the model's convergence behavior. Custom losses might require different learning rates or additional monitoring to ensure performance is on track. Debugging integration issues often involves checking for mismatched dimensions or unexpected NaN values. By carefully monitoring and adjusting the training loop, you can harness the full potential of your custom loss function. Testing and validating your custom loss function is crucial to ensuring it performs as intended. Start by running simple test cases to check for errors in the loss computation. Use validation datasets to assess how well the model generalizes using the custom loss. Compare the results against those achieved with standard loss functions to identify any improvements or regressions. Handle any unexpected outputs by revisiting your loss formulation and ensuring it aligns with your problem's objectives. This might require iterating on your design and tweaking parameters. Through rigorous testing, you can confidently deploy your custom loss function, knowing it enhances your model's capabilities.
Designing custom loss functions comes with its set of challenges. One major pitfall is overfitting, where the model becomes too tailored to the training data. To avoid this, ensure your custom loss function is as simple as possible while still capturing the necessary complexity. Differentiability is another key aspect. Your loss function must be differentiable to enable gradient-based optimization. Be mindful of numerical stability issues, such as division by zero or overflow errors, which can derail training. Striking a balance between complexity and interpretability ensures that your loss function not only performs well but is also understandable to stakeholders. Debugging custom losses often requires checking gradient flows and validating outputs at every step.
Optimizing your custom loss function for performance is essential for efficient model training. Start by profiling your loss function to identify bottlenecks, using PyTorch's built-in tools or external libraries. Once you pinpoint areas for improvement, leverage PyTorch's optimizations, such as GPU acceleration and mixed precision training, to enhance speed without sacrificing accuracy. Iterative testing can uncover further performance gains. Small tweaks can often yield significant improvements. Always balance speed with the accuracy of the model, ensuring that optimizations do not compromise the quality of the results. With careful performance tuning, Your custom loss function can run efficiently even in demanding scenarios. To truly understand the potential of custom loss functions, let's look at a real-world example. Consider a project where a team developed a custom loss function for a medical imaging application. By customizing the loss to penalize false negatives more heavily than false positives, they significantly improved the model's sensitivity, which was crucial for early disease detection. This case study highlights the importance of aligning the loss function with specific problem requirements. Lessons learned include the need for thorough validation and the benefits of iterative design. As machine learning evolves, custom loss functions will increasingly play a role in solving complex and domain-specific challenges.
As we wrap up, remember that custom loss functions are more than just a technical exercise, they are a powerful tool to enhance your model's training process. We've covered everything from the basics of defining a custom loss to integrating and optimizing it in your PyTorch workflow. Now, it's your turn to experiment and see how custom loss functions can transform your projects. Share your experiences and any questions in the comments below. Don't forget to like, subscribe, and let us know what topics you'd like us to cover next. Your engagement helps us bring you more valuable content.